Alright, let's solve question number 16 together. Question number 16 says solve and express the answer of these exponential equations best up to 3 decimal places. They have given us 2 power x times 3 power x equal to 10. Now that's a product of two numbers which have the same exponent, which have the same power. We know this property of exponential numbers, that when you have same power over the product of two different bases, you can just multiply the two bases and express them under the same power, the single power. So this way I can just put this power x over the top of multiplication of 2 and 3. So now 2 3s are 6. I get 6 power x equal to 10. I need to find the answer of x. So for bringing x down, we need to apply log on both sides. We take LG 6 power x equals to LG 10. X comes down, it gets multiplied with LG 6. So x times LG 6 equals to LG 10. I'm interested in the value of x. So x will be equal to LG 10 divided by LG 6. The value of LG 10 is 1. The value of LG 6 is 0.7781. If I divide 1 with 0.7781, I get the value of x equal to 1.285. In a very similar way, we solve the next part, which is 4 power x equals to 9 times 5 power x. Again, there are two different terms which have a power of x. So I bring 5 power x down in the denominator of 4 power x on the left hand side. So I have 4 power x divided by 5 power x equal to 9. These two terms have the same power, so I can write 4 upon 5 under a single power. So I have 4 divided by 5 power x equal to 9. I know 4 divided by 5 is equal to 0.8. So 0.8 raised to power x equals to 9. I need to bring this x down. We apply log on both sides. So log of 0.8 power x equals to log of 9. X comes down in the multiply. X times log 0.8 equals to log 9. I need the value of x, so we divide log 0.8 on both sides. I have log 9 divided by log 0.8. The value of log 9 is 0.9542. The value of 0.8 is negative 0.0969. If I divide these two numbers, I get x equals to minus 9.846. The similar way, C part asks us to find the value of x if 2 power x plus 1 is equals to 3 power x. I have a variable x in the exponent on both sides. There are a number of ways I can simplify this first and then apply log, or I can directly apply log and then simplify. So I have taken the second approach, to apply log first and then simplify. So we have log of 2 power x plus 1 equals to log of 3 power x. In both of the cases, the exponents will come down. So x plus 1 multiplied by LG2 equals to x multiplied by LG3. Now this LG2 gets multiplied with both x and 1. So it's x times LG2 plus 1 times LG2. 1 times LG2 is LG2. So we write it as LG2 equals to x times LG3. Now we separate the variables and the constants. So I keep LG2 as it is on the left side and bring x times LG2 to the right side. So it becomes negative x times LG2. Now if we take the x term that is multiplied with both terms as a common, so we factor out x, we are left in the bracket with LG3 minus LG2. We find the value of LG3, which is 0.4771, minus the value of LG2, which is 0.3010. We put the value of LG2 here as well, which is 0.3010. We simplify this term. The difference of 0.4771 and 0.3010 is 0.1761. We divide this number on both sides, so the x value that we get is 0.3010 divided by 0.1761. If we do the division, we get x equals to 1.709. So if we have common bases, we add the powers in multiplication or subtract the powers in division. If we have common powers, we write the bases as a product or as a division when we are simplifying them. In question 17, they have given us 3 power x plus 1 times 2 power x minus 2 equal to 21, and they say show that when you simplify this it will be 6 power x equal to 28. In addition to that, they say if you simplify this and get this result, with the help of that or otherwise find the value of x. So we need to simplify it, and then with the help of that simplification we need to find the value of x. So we take 3 power x plus 1 times 2 power x minus 2 equals to 21. I know 3 power x plus 1 can be written as 3 power x times 3. The similar way, 2 power x minus 2 can be written as 2 power x divided by 2 power 2, because we know when bases are same, in multiplication power should be added and in division power should be subtracted. On the right hand side we have 21 as same as it was given. So now we take 3 power x and 2 power x, they both have an exponent of x to them, so we keep them together, and 3 and in the denominator we have 2 power 2, they are constants, so we keep them out. So I have 3 power x times 2 power x multiplied with 3 divided by 4, because 2 power 2 is 4, and all of that product is equals to 21. Now 3 power x times 2 power x becomes 6 power x equals to, if I multiply 4 on both sides and divide 3 on both sides, I get rid of this constant term 3 by 4, so that gets multiplied and divided with 21 on the right hand side. The 21 divided by 3 would be 7, 7 times 4 would be 28, so I got 6 power x equals to 28. I needed to show that, I did it. Now using this we can solve it for x. So we have an exponential equation in x, we take log on both sides, x comes down in the multiplication, x times log 6 equals to log 28. So we take log of 28 divided with the log of 6, we get our answer. The similar way, in question number 18, they ask us to find the value of x correct to 3 decimal places. So the first part is 5 power x minus 1 times 3 power x plus 2 equals to 10. We break it into simpler terms. 5 power x minus 1 can be written as 5 power x divided by 5, the division property of the exponent, multiplied with 3 power x plus 2 can be split into 3 power x times 3 power 2. Okay, this should be 3 power 2 in multiply, not in divide. I did it wrong. It's for you people to fix it. So just convert the divide part into multiplication and do it again. You will get the answer. I'm sorry for this mistake. So what I have solved is for x minus 2. Your book has it in x plus 2. Just do it again. Let's do part D together. So we have 3 power x times 10 power 2x equals to 4 times 20 power x minus 2. We simplify that also. So I keep 3 power x as it is. 10 power 2x can be written as 10 power 2 whole power x. We know that if you have an exponent over number and then you have it raised to another exponent, both of the exponents get multiplied with each other. So 10 power 2 whole power x will be equal to 10 power 2x. On the right hand side I have 4 multiplied with 20 power x minus 2, so it can be written as 20 power x divided by 20 power 2. If I simplify, we get 3 power x times 10 power 2 is 100, so that becomes 100 power x equals to 4 divided by 20 power 2 is 400. So if you square 20, you get 400 times 20 power x. Now we keep the constants on one side and move the variables on the other side. So 20 power x comes in the denominator. 3 times 100 is 300 raised to the same power x. So we have 300 power x divided by 20 power x equals to, if we simplify 4 divided by 400, I get 1 divided by 100. So the simplification of 1 over 100 is 0.01, and on the left hand side when you divide 300 with 20 you get 15. So 15 power x is equals to 0.01. We have a simple exponential equation. It's 15 power x equal to 0.01. We take log on both sides, so I have lg 15 power x equals to lg 0.01. We simplify it and get the value of x to be negative 1.7005.